Balancing redox reactions in acidic solutions. Balance the following reaction and determine the volume of a 0.850 molar potassium dichromate solution required to completely react with 5.25 grams of copper. So in this reaction, I don't see any potassium, but I do see dichromate. So if I just look at the potassium dichromate by itself and I split it up, I would form 2 potassium ions and 1 dichromate. So 0.850 molar of K2Cr2O7 with a mole-to-mole ratio is also the same for dichromate by itself. So I'm going to write here that I have 0.850 molar of dichromate and I have 5.25 grams of copper. So I want to know the volume here. So I wanted to know, the volume. In order to find that, I'm going to need to use molarity. I know that molarity is equal to mole over liter, so I can find the volume from that. So I need to find the moles. Well, I'm not given anything about moles specifically of dichromate, but I'm given mass of copper. And I know that I can use the mass of copper to go to moles using molar mass. So I can take my grams of copper and go to moles of copper using molar mass. Okay? And then, because I want to go from one to another, I know that I have to use mole ratio. I can go to mole of dichromate using mole ratio. And then go to volume of dichromate using molarity. So there I have my plan. So I know whenever I have one compound to another, I need to use the mole ratio. So I use whatever I'm given and needed to end up with to find the moles and then convert to the given unit. Here I'm given grams of copper, and I can use the molar mass to get to moles of copper, the mole ratio to get to dichromate, and then use its molarity to find the volume. Now, in order to use the mole ratio, I have to make sure that I'm balanced. This is a redox reaction in acidic solution specifically. Without that being told to you, however, just looking at the reaction, you can already see that there's a bunch of charges there, and they have to be balanced. And also, there's an oxygen here on the left side, but not on the right. So how would the elements even balance out? So the first step is to write 2 half reactions. So split full equation into 2 half reactions. Cr2O7 2 minus will be split with Cr3 plus, chromium 3 plus ion, and copper solid with copper 2 plus. So I did my first step, split the full equation into 2 half equations. Now balance the elements by adding coefficients. Well, my second question just has copper and copper, so that's finished. And if I look at the next one, I have 2 chromiums here, so I'm going to place a 2 here. Now my chromiums are balanced. Now I still have this issue, actually I'm going to stay in black, I have this issue where I have 7 oxygens on the left but no oxygens on the right. This is where in an acidic solution water comes into play. Balance the oxygens by adding water to opposite side of the equation. So if I have 7 oxygens, I'm going to add 7 waters to the other side. Now my oxygens are completely balanced. Step 4 says balance newly added hydrogens by adding hydrogen ion to the other side. Adding these 7 water molecules balanced out my oxygens, but I created a new problem by now having hydrogen ions that I do not have on the left side. So to balance that, I'm going to add the amount of hydrogen ions to balance out. 7 times 2 is 14, so 14 hydrogen ions. Determine the elements being oxidized and reduced and add loose electrons from half reactions to balance the charge. So now I have to balance the charge and know where the electrons were gained and where they were lost. And the best way to do that is to determine which one is oxidized and which one is reduced. So copper has a 0 oxidation state on the left side because it's its neutral state, and copper 2+ has a positive 2. So this means that copper went from 0 to positive 2. Well, that means that it lost 2 electrons because it became more positive. So I'm going to add a 2 minus 2 electron negative on this side. Well, I know that if copper was the one that was oxidized because it lost electrons, then chromium was the one that reduced. It means it gained electrons. But just to make sure, I'm going to calculate here on this side the oxidation state for chromium. I have Cr2O7 2 minus. So I know that I have 2 chromiums plus 7 oxygens, which has to equal negative 2. Oxygen is always negative 2, which times 7 is negative 14. If I add the 14, I have 12. So chromium is plus 6. So chromium goes from plus 6 to plus 3. This went down in number, so it gained. So chromium gained, I'm going to write that over here, 3 electrons. Perfect. Determine the elements being oxidized and reduced. So we did that. Now sum the equations together. Manipulate both to cancel out the electrons. Well, in order to get rid of these electrons, I'm going to want to make them the same number. So I'm going to multiply the top by 2 and the bottom by 3. And then I'm going to write my new equations. 2 times 14 is 28. So I have 28 hydrogens plus 2 chromiums plus 6 electrons, 4 chromium 3 plus ions, plus 14 water molecules. And then I have 3 copper solid and 3 copper ions, and then 6 electrons. And now I can sum them together and cross out my electrons. So my 6 electrons, since they're on the opposite side, would cancel, and I can sum up my equations. A little crammed here, and now I'm finished. Well, now I can use the balance reaction to solve the problem. Boom. So I go back to my plan here, and I start with my 5.25 grams of copper. Well, if I want to go to moles of copper, I will need to use the molar mass of copper, which, if you look in my periodic table, is 63.55. So then I can use my mole ratio, which is 3 to 2. So 2 moles of dichromate over 3 moles of copper. And now, since I want the volume, I can use the molarity to get the volume. 1 liter over 0.850 molar. And even before plugging it in, I can always double check. The grams will cancel. So 5.25 divided by 63.55, that cancels out your grams of copper, times your mole ratio, cancels out your moles of copper, and then divided by the molarity, cancels out the moles here. This should be moles. And you're left with liters. So you did it right, and plugging that all in gives you 0.06479 liters. And We have 3 significant figures, so 0.0648 liters is the answer. So in the end, it was just a stoichiometric equation solving from what we're given, whether it's mass, molarity, density, etc., knowing that when you go from one compound to another, you have to use the mole ratio. The only difference is it's important to balance. However, this was a redox reaction, so you had to balance out your electrons and the elements. First thing is to separate the big equation into 2 half reactions and see what you're dealing with. Then using water and hydrogen ions to balance out the appropriate elements. Then determining whether electrons were lost or gained to balance out the charges. Manipulating the equations to get an overall equation that is balanced with charges and elements. And then going back to solving the problem based off of stoichiometry.